Hi, my name is Mohit Vyas, and today we'll discuss problem B of Codeforces, round 893, div 2, the walkway. So the problem goes like, there is the problem goes like there are n benches in the main walkway. I'll briefly explain. You can read the problem from Codeforces only. There are one benches numbered as 1 to n. 1 to n number of benches are there, and at any ith bench there is one cookie seller. There can be one cookie seller. So there are m number of cookie seller at bench number Si. So Peta will move start from bench number 1 and goes up to bench number n, and at any bench uh, Peta can eat maximum one cookie, and there are three conditions. If any one of these conditions is satisfied, then Peta will eat the cookie. So we'll briefly read the condition. The first condition is, if there is a seller at ith bench, then Peta will eat the cookie. If PETA has not eaten any cookie yet, then also PETA will eat. And if at least d minutes passed since PETA ate the previous cookie, then PETA will eat. And one more condition is to move from bench number I to I plus 1, the number of minutes taken is 1. So 1 minute will require to move from one bench to next bench. You have to minimize the number of cookies that PETA will eat, and we can remove exactly one, like we should remove exactly one cookie seller from 1 to n number of benches. There might be there are n number of cookie seller. We have to remove exactly one of them, and we have to tell that what's the minimum number of cookie that PETA has to eat. And we also have to tell that what are the different possible options that we have, like what are the number of sellers that we can remove, so that the cookies eaten by PETA remains minimum. This is the problem statement. You can read it from Codeforces for better understanding. I'll focus on solution more. So there are input given as n, m, and d. So n is number of benches, m is number of cookie seller, and d is this parameter as mentioned in the question. And there is one more array, that is the position of ith cookie seller, right? And it is guaranteed that the m will not exceed this. Means this problem should be solved within n or maximum up to n log n. Right? This cannot go. The time complexity cannot go beyond that. So we will see the test cases. We'll see first test case. The input given as 6 to 2. This is n, this is m, and this is d. So there are 1 2 3 4 5 6 number of benches, and out of which at bench number 2 and at bench number 5 there is a cookie seller. So if we will not remove any cookie seller, then how much cookies that PETA will eat. So we'll see. PETA will start from position number 1. At position number 1 we will see if any of these three conditions is satisfied or not. So we can see second condition is getting satisfied, so PETA will eat the cookie. Means PETA has not eaten any cookie yet, so PETA will eat the cookie because of condition number 2. Now at now PETA will move to next bench in 1 minute, and after 1 minute here PETA will come. We'll see if any of the condition is satisfied or not. Yes, we can see there is first condition that is satisfied, that is the seller is there at position number 2. So PETA will eat the cookie because of condition number 1. So these are the condition I am writing, right? Now PETA will move to 2 3, and none of the condition is satisfied, so PETA will not eat any cookie. Now PETA will move to condition number 4, and second the third condition will be satisfied. At least d minutes passed. D is what? 2. So how d minutes will passed? PETA has eaten cookie at position number 2, and after 1 minute PETA moved to uh, bench number 3. 1 minute has passed, and after 1 minute PETA has moved to 4. So we can see 2 minutes has passed, and d is also 2. So PETA has to eat the cookie because of condition number 3. Now PETA will move to 5, and here first condition will satisfy, as you can see in the input that there is one cookie seller. So here PETA will eat because of condition number 1. then we will move to bench number 6 and no cookie will be eaten by PETA. So if we don't remove any of the seller, then maximum number of cookies that PETA will eat is 4. Right? Now, according to the question, we can remove exactly, we have to remove exactly one seller. So which seller we will remove, that we'll see. So 1, 2, 3, 4, 5, 6, and seller is at position number 2 and position number 5. So first, let's see if we remove the seller from position number 5. Let's say we have removed this one. Now see what will happen. At position number 2, PETA will eat cookie according to the condition number 2. You can see the condition and understand. And at position number 2, PETA will eat the cookie according to, because of condition number 1, since there is already the cookie seller. At position number 3, 1 minute will be required, but here PETA will not eat any condition. These are just similar to previous one only. And at position number 4, PETA will eat because of condition number 3. Here now PETA will not eat any cookie because we have removed this cookie seller from there. And at position number 6, PETA will eat because of condition number uh, 2, sorry, 3, because d minutes has passed, 2 minutes has passed. How? PETA has eaten cookie here, PETA has eaten cookie here, and after and up to 5, 1 minute passed, up to 6, 2 minutes passed, and do is also 2. So here PETA will eat. So the number of cookies eaten will be 1, 2, 3, 4. So here also 4, no change you can see. Now if we remove the uh, cookie seller at position number 1, this cookie seller we remove, 3, 4, 5, 6. So second one we have removed. Now only cookie seller is at position number 5. We will again start at position number 1. PETA will eat the cookie because of condition number 2, that PETA has not eaten any cookie yet. Now at position number 2, PETA will not eat any cookie because none of the condition is satisfied. So here no, he will not eat. PETA will not eat. Here PETA will eat because 2 minutes has passed. 1, 1, 2 minutes has passed. So because of condition number 3, PETA will eat the cookie here. Here PETA will not eat because none of the conditions is getting satisfied. Here PETA will eat because of condition number 1 as well as because of 3. According to condition number 1, there is one cookie seller. According to condition number 3, uh, 3 2 minutes has passed. Okay, so here PETA will eat according to 1 or 3, and here PETA will not eat. So now you can see the maximum number of cookies eaten is 3. Sorry, the number of cookies eaten is 3. So this is less than this one, and there is only one option that we can remove in order to minimize the number of cookies eaten, and that is number 2. Sorry, uh, uh, the seller at this position, that is first seller, right? So this is how it goes. So now we'll move to solution. Now we'll move to solution. So this is a sort of greedy approach only. So how we will proceed with solution? We are given 1, 2, 3, 4, 5, 6, 7, 8 up to n, right? And there is any cookie seller at position number I. Okay, one more thing. The condition number 1 can only be satisfied at first position, because we are going to first position, and if there is no cookie seller, then we must have to eat the cookie according to condition number uh, second, right? According to second condition. And once we have eaten first cookie, then second condition will not come anywhere, right? So at bench number 1, we must have to eat the cookie at any cost. Either there might be cookie seller, or even if there is no cookie seller or no d wala condition is satisfied, then also we have to eat because of condition number 2. So this is sure that we will definitely eat one cookie at position number 1. Now at any position I, we will eat cookie because of condition number, either because of condition number 1 or because of condition number 3. So what's the condition number 1? That is, if there is a cookie seller at bench number I, or d minutes has passed. So these are the two conditions because of which we will eat the cookie at any ith bench. You are getting? So let's say I is 6. So we will see what can be the conditions because of which we can eat the cookie at condition number 6. So either condition is, let's say D is given as 3. So if we have not eaten any cookie, let's say last cookie we have eaten at 3, 4, 5, right? Last cookie we have eaten here, and here there is no seller, then we have to eat the cookie at position number 6. And if there is a if there is seller, then definitely we have to eat. So let's consider there are some sellers: 3, 4, 5, 6, 7, 8, 9, 10, 11. There are some sellers at position, let's say 3, 5, 8, one more 12, 13 is also there. So there are some sellers at these positions. We will start, and D given is 3. So we will start at 1, we have to eat, and at any position if there is a seller, then if we remove, we will see greedily that what if we remove each seller in the seller array. Seller array is given as 3, 5, 8 and 12, means at these positions we have the seller. We will see greedily if we remove any any ith seller, then what will be the change in number of cookies eaten by PETA. So if we remove any seller, let's say we have removed seller, this seller we have removed. So what things can change here? You can see if we remove this one, then then the things before this one will not change, and things after this one will not change. Only change that can happen is within this range only. And in this range, what is the number of cookies that PETA can eat? So that are here. This is for sure that PETA will eat the cookie, and after that PETA has to, if we don't remove this one, then PETA has to eat the cookie at 5 also because of condition number 1. And if we remove this one, then within this range, if PETA will eat the cookie, then these will be only because of condition number 3. This cannot be because of condition number 1, because in this range, we have removed this 5, right? So we'll see that if there is any benefit because of this or not. So at each position we have to see that if we remove this seller, then there will be any benefit or not. So in this range only we will see. Now the problem reduces to this range only. If we want to remove any ith seller, then we have to see in the range of this previous seller and next seller. Within this range we have to see, after that we don't have to see. So here what's there? At 3 we are eating anyway, at 5 we are eating, and at 8 also we are eating. And here D is given, let's say not 3, let's say D is given as 4, right? So this is before removing the fifth seller. Now if we remove the fifth seller, so what's in between? We'll see 4, 5, 6, 7. So this is in between. So at these three positions we are eating. Now if we remove the fifth one, then what will happen is at 3 we will definitely eat, and at 8 also we will definitely eat. If we remove the seller from here, 4, 5, 6, 7. So if we remove the seller from here, then PETA will start from here, and he'll see if up to D is equal to 4, if there is no seller, then the PETA has to eat the cookie because of the condition number 3. So 1, 2, 3, 4. So at 7 PETA has to eat. So then also the number of cookies eaten will be 3, and before removing this one also the number of cookies eaten will be 3. So that means we can see there is no change, right? There is no change. Now the same condition we will see if the D is equal to 5. Now what will happen? 3, 4, 5, 6, 7, 8 seller are at these positions. Now if we don't remove the seller from position number 5, then the cookies eaten will be 3 within this range. And if we remove the seller from this position, 3, 4, 5, 6, 7, 8. If we remove the seller from position number 5, then here the cookie will be eaten. But 1, 2, 3, 4, 5. The third condition is getting satisfied at position number 8 only, and at 8 anyway we are eating the cookie. So now the cookie eaten will be 2. So here we are getting the benefit. So but when d was 4, then we were not getting the benefit. So as you can see, from these two observations, if you observe carefully, you can see that the if we remove this one, then this gap, which is 2, and this gap which is 1. So like if we remove this one, then this gap is anyway, if this gap, if this gap after removing this one is less than or equal to d1, d, then we will get the benefit, otherwise we won't get the benefit. So we will understand it with one more example, and let's take the example as, we'll take one range only, right? So one range is, let's say, 22 and 24 and 30, and d given us 8. Sorry, initially d was given as 7, let's say. So within this range there are, there is two gap, that the gap is 2, and here the gap is 6, right? Now if we remove 24, if we don't remove 24, then we have to eat the 3 cookies. As you can see, the third condition won't satisfy. But if we remove the 24, then we will see how, see, we cannot directly jump to 30 from 22. Why? Because the then the gap will be 8, and which is greater than this one. So we have to, anyway we have to go to 29, which is 22 plus 7, right? D is equal to 7, and after that we anyway have to go to 30. That means in this case, if we remove 24, then there will be no benefit. But at the same time, if the d is 8, 22, 24, 30, if the d is equal to 8, then this gap is 2, this gap is 6, and if we remove 24, now we are eating 3 cookies. If we remove 24, then we can directly jump to 30 without eating any cookie in between. So now we have to eat only 2 cookies, right? So by this observation we can say that we can save at most, we can save at most one cookie, one extra cookie we can save at most. But for that the condition should be this difference, this difference, and this difference, the sum of this difference, d1 plus d2, should be less than, or equal to d, right? This is the given d. So if this condition is satisfied, then we can definitely save one extra cookie eaten, right? And this d1 is not the direct difference, that this is actually the difference m percent of d, because instead of this 22 and d is at 22, 24 and 30. So if there can be, instead of this 22, there can be 22 minus d, that is 14. So 14 can also be there. So anyway we will jump, because of d, d is equal to 8, we will jump to 22. So even if there is 14, then we will not take the interval of d, because that anyway we have to jump. So we have to take only its m percent. So difference m percent we will take, right? So this is one of our observation. uh, by this we can conclude that, first we will calculate the total number of cookies eaten, total number of cookies eaten by PETA, and after that we will iterate over the given array, that is s1, s2, s3, s4, and we will see if we can remove s2, if we can remove s3. S1 and s4 we will see as a separate case. So we will go to each position, and we will see if we can remove any of these. Removing any of these means, is removing any of these saving some cookies eaten or not? I mean, removing any of these sellers is getting, is giving reduction in number of cookies eaten or not? If yes, then we can say that we can definitely remove the particular seller. If not, then we can say that we cannot remove this seller because this is not giving us any benefit. So and we will also consider the corner case. So now we will move to code. So this is the code part. So here what I did, this is the input that I have taken, and this is the array that I have taken, and here I am calculating the total number of uh, cookies that Peta has to eat without removing any of the seller. And here what I am doing is, here what I am doing here I am doing is, if the given array is starting from 1, let's say there is already one seller at position number 1, then I'm incrementing this one, because that one case anyway, whether there is seller or not, we will anyway have to eat the cookie there because of condition number 2, right? So if there is already the seller, then we will consider that the seller is starting from its next position, right? So that's why I put this condition. And this PR is the previous position of the previous seller. So what I'm doing, that while I is less than m, i'm I'm doing total as array of I. I mean the current position. Let's say the current position is given as 3, 5, 8, and currently d is equal to 2, right? So initially this is the array that is given. So we'll try run it with this example. So d is equal to 2 is given, and n is, let's say, 10, and d is this one, and m is obviously 3. This is the array given. So the first number is not 1. So the pointer, that is I, is here only, and previous one is 1, because at position number 1 we have to Peta has to eat the cookie. So and the currently the total is 1. When the pointer will move here, so first we will calculate the difference, and the difference is this one. So the difference is anyway. Acha, oh, okay. And this minus 1 I am doing because at this we anyway have to eat the cookie. So I am doing this one, that is 3 minus 1 divided by d, which is equal to, I think, 0. This is because either we have to eat, I mean how many cookies we have to eat because of condition number 3. So this will add that one, and again we are doing total plus plus because we are eating the condition, we are eating the cookie because of condition number 1, as there is already one seller. And after that we are updating this previous one as this one, and I also we are updating to this one, right? So when I will be here, then again we will do the same. That is 5 minus 3 minus 1 divided by 2, which is equal to 0. That means we don't have to eat any cookie in between because of condition number 3. And again we are doing total plus plus because we have to eat the cookie at position number 5 because of condition number 1. And again we are incrementing I. And here when we will come here, then this will come will happen as so this 8 minus 5, 3 minus 1 divided by 2, which is 1. That means at 5 we have already eaten, 6, 7 is there, 8 at 8 already we have to eat, but in between also we have to eat one cookie because of condition number 3, as d is equal to 2, and there is the gap of 2 or more. So this we are adding in this condition. And again we are doing total plus plus because at 8 also we have to eat the cookie. So this is how we have to well calculated that what how we have to take the total number of cookies. Sorry, how we have to count the total number of cookies. And at the end we are taking that, let's say this is 8 only and n is 10. So after that also 9 and 10 is there. So we have to see that if we have to eat the cookie because uh, by going there or not. So that how we are doing, we are simply subtracting 10 minus 8, that is 2 divided by 2. That means we have to eat one more cookie there because of condition number 3, because there is a gap of more than d. So this is how we are calculating total. And here this flag doesn't mean anything. I coded it like, yeah, this flag doesn't mean anything, just forget it. Again I am doing this ind also doesn't mean anything. I'm again setting I as 0, and if array of 0 is 1, then I plus plus I am doing. And now what I am doing is I am traveling up to m minus 1 index, right? And here what I am doing is I am calculating its previous reminder, as you can see here, I am calculating this gap, right? This 22, 24. So this reminder I am calculating. So this is the reminder number one, which is, yeah, this reminder I am taking, and if this reminder is 0, then I am setting this reminder as D, because you can see if there is 24 and if D is if there is 16 and this gap is 8, but if we do 8 m% 8, then this will give us 0. So to avoid this condition, I am setting, if this is 0, then we should set it to 8. And similarly we are I'm taking the reminder from right side, and I'm also doing the same for this one also. And I'm checking if this reminder 1 plus reminder 2 is less than or equal to D, then I'm incrementing number of sellers that we can remove plus plus. This is the number of sellers that we can remove, so I'm doing it plus plus, right? And similarly I'm doing for all I, and this condition doesn't mean anything. And now at the end what I'm checking is, I am checking for the last one, right? If we can remove the last position or not. So for the last position also I am doing same, right? So if NOS is equal to 0, that means up to here what I did is, NOS means number of sellers that I can remove. I am updating only when removing any seller is creating any difference in minimum number of cookies eaten by PETA. But if it is not creating any difference, then this NOS will not update in this algorithm up to here. So now what I will do, if the no one, no none of the seller is making any difference, then I can see that, then I can simply say that, although it will not reduce the number of cookies eaten, but we can remove, then we can remove any of the seller, right? So number of sellers that we can remove will be m in that case. Otherwise, if any, if removing any of the seller is creating any difference, then total will be reduced by 1, because that one, that difference of that one will be encountered in our minimum number of cookies eaten. So that we will, that we are, finally printing out, and that solution has been accepted. So this is all about this problem.